Lesson 27 for 3 polynomials. Today we're going to look at the types, the degree, and the form of polynomials. For today's success, you'll want to note and become familiar with today's vocabulary. Coefficient, we talked about it before, it's the number in front of a variable. A polynomial, basically everything we deal with today is a polynomial in some way, shape, or form. There's just more specific names other than polynomial. We talked about what a monomial is. A monomial. A binomial is a sum or difference of two monomials. Trinomial, sum or difference of three monomials. Anything above that trinomial, we basically just call it a polynomial. We'll also talk about the degree of a polynomial, which is the greatest degree of any term in the polynomial. We'll be writing standard form of polynomial and talk about a leading coefficient. You also want to reference the table degree of polynomial and the different names. So when we get in discussing the degrees of a polynomial, we'll reference this chart here. Remember that you're able to pause the video at any time. I'll probably work through 3 problems and then have you pause the video and go ahead and try to work through a few on your own. We're going to determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. We look at the first example here. We have 4y minus 5xz. If you look at the top of your paper, we need to determine from the 3, is it mono, is it bi, or is it tri? In this case, it would be a binomial. There's a difference of two monomials. We have a difference here of the two monomials. So we would state that this is, yes, this is a polynomial, and it is a binomial to be specific. B. We look at B here. Again, yes, this is a polynomial. This is a monomial. It has one term. There is no sum or difference there. Remember, this is also called a constant. Example 3, if we look at it, most of us want to say yes, that this is a polynomial. And the type of polynomial that this would be a binomial. However, that is not the case. Reason being is, if you look at this, we have 7a to the negative third plus 9b. Remember, we worked with getting rid of negative exponents. A has a negative exponent. A is in the numerator, therefore it needs to be moved to the denominator. When you move it to the denominator, it would look like this, 7 over a to the third. Remember, you cannot have a variable as a denominator, so therefore this is not a monomial, this is not a binomial, this would not be a polynomial. So C is no, this is not a polynomial. Reason being the negative exponent. I'm going to go ahead and have you try to work through D, E, and F, or sorry, D, E, and F. It should be. There's a error there on the page. All right, when most of us worked through the problems here, a lot of us probably wanted to say that D is an example of a polynomial because of the 4 terms. However, you need to remember there are like terms here. You can add that together. So you need to simplify your problem. You can add 4x and x. Okay, when you add this together, it is no longer 6x squared plus 4x plus x plus 3. It is 6x squared plus 5x plus 3. Adding these 2 terms together, making this a trinomial. Yes, it is a type of polynomial. It is a trinomial. E, we kind of covered up in C. Look at E here. We have a variable as a denominator. This is not a polynomial. Okay? Monomials will not have a variable as a denominator. In the last example here, we look at it. We look at our terms. There's no negative exponents. This is a polynomial, and it is a trinomial. In example 2, we're going to find the degree of a polynomial. Remember, the degree of a polynomial is the greatest degree of any term in the polynomial. You can also reference this chart. Okay, here are your degrees of a polynomial: 0, 1, 2, 3, 4, 5, and 6 or more. That's just the degree. On your assignment, I know you're eventually going to have to name it. So once you find the degree, and then you will need to name it. And here are the names of the specific types of polynomial. In our example, we're just going to find the degree of each polynomial here. So in A, we have 6, a to the second, b to the third, plus 9. In order to find the degree, you kind of break things down. Break each of the monomials down. Here's your first monomial: 6, a to the second, b to the third. Okay? When you break it down, what you have to do, remember that the degrees hinge upon the exponent. So a is squared, b is cubed. 2 plus 3 would give us 5. And down here, 9, it does really have an exponent of 1, but you're focusing on the variable aspect of it. So we would call this a fifth degree. Okay, that is the highest degree of the polynomial. Again, on your assignment, you'll ask to name it. Right here, we're just finding the degree. And if you were to name it, if you look at the chart above, you'd call that a quintic. Okay, fifth degree is a quintic. So when naming, that's what you would do. In B here, again, break things down. Break your three pieces of this trinomial down. You have 8d to the fifth, 12c to the third, d to the fourth, and 7. Again, we want to add the exponents together. D has a power of 5, c has a power of 3, d has a power of 4, so we'd add that together, giving us 7. And we would call this, well, looking at the degrees here, we have 5, 7, and 0. This would be a 7th degree. And note, on the table above, anything over 5, we really don't have a name for it, so the name is 6th degree, 7th degree, and so on. I'm going to go ahead and have you guys pause the video here, work through C and D, and then check back in. In example C, we have a monomial here, and we need to find out the exponents. A would be 1, B 4, C 3. We'd add that together, and we'd get a 6th degree polynomial here. Same in question D. Go ahead, break that down, break each one of those terms down. This is an example of a polynomial because it has 4 monomials. Break it down. You should have had something like this on your paper. Finding out here is our highest degree. So this would be a 5th degree. Remember the 5th degree, the name of that, and you can write it down, is quintic. And that would be off the table above. The last portion of our assignment here, and you guys have actually kind of been introduced to this before, there is a way normally you write these terms out. Normally you just focus on if it's positive or negative, but we should get in the habit of writing our polynomials in standard form. And here's how you write polynomials in standard form. In example 3, we're going to write it in standard form and identify the leading coefficient. I'm just going to reference the 2 vocabulary terms that you have on your paper. Again, standard form here. Writing the terms in order from greatest degree to least degree. Greatest to least. Leading coefficient is the coefficient of the term with the highest degree. So we'll check back in our examples here. We look at example 1. Example 1 is not in standard form. We look at our degrees. First thing, I would break this trinomial down into degrees. 4x squared, well, that has a degree of 2. 9x to the 5th has a degree of 5. The negative 7x has a degree of 1. Remember, putting things in standard form, you're going to write your greatest degree first. In this case, that would be 5. This is a positive 9x, so make sure you put 9x, show that as positive. The next one would be 2. So we would have a plus, because it's a positive 4x, so 4x squared. So you'd have 9x to the 5th plus 4x squared, followed by the negative or minus 7x. It's critical that you look out to the sign in front and carry that sign if it's positive or if it's negative. Remember, the leading coefficient we also need to identify. That is the coefficient out in front of the highest degree. In this case, that would be 9. Easily to pull out once you write it in standard form. So your leading coefficient here is 9. Example B, same concept. I just drew my arrows in there. I'm going to go ahead and figure out the degrees based upon my variables. 9y, exponent of 1. No variable present here, so we're not going to have the degree. Y to the 4th would have a degree of 4, and 5y to the 3rd has a degree of 3. Once you have that out, very easy to pull the terms out for standard form. This would obviously be written first. The biggest thing, again, make sure you carry the sign. So you should have a negative 9y to the 4th first, followed by positive 5y to the 3rd, positive 9y, followed by negative 9, or minus 9. Leading coefficient is negative 9. Again, I'm going to go ahead and have you guys pause the video, work through C and D on your own, and then check back in. All right, you've worked through C and D on your own here. I'll just go ahead. You can kind of double up, check things out, see if your work aligns to mine. Here's your standard form: 6b to the 3rd plus 11b squared minus 15, and your leading coefficient 6. In D, here's your standard form: negative 9w to the 5th plus 5w to the 3rd minus 3x squared plus w minus 10, and our leading coefficient is negative 9. This will conclude our lesson on lesson 27, 4.3 polynomials.